Imagine a world where data isn't just static but dynamic, always evolving through interactions and updates. In the realm of GraphQL, this dynamic interaction is handled through something known as mutations. Mutations are essential for performing write operations on the server, such as creating, updating, or deleting data. Unlike queries that fetch data, mutations change data. Diving into the structure of a mutation, consider the task of creating a new user. A mutation is defined with a specific operation name. In this case, this operation takes an input object with fields like name and email, and it returns details of the newly created user, including their ID, name, and email. This process ensures that not only is the user created, but their information is immediately retrievable in the response. To implement this, one must define mutations in the GraphQL schema. For the mutation, the schema includes a type where is a field. This field uses a defined input type requiring a name and an email, both marked as non-nullable with the exclamation mark. The mutation responds with, which includes the type, detailing the ID, name, and email of the user. Expanding on this, consider a more complex mutation, such as creating an order. This mutation involves nested input types and multiple fields, including user ID, items array, and shipping address. Each item in the order and the address details are specified in the input, and the mutation returns comprehensive details of the order, including each item's product information and the shipping address.
Consider the use of variables. Instead of hard coding values, variables allow developers to pass data dynamically. This method not only simplifies the mutation, but also secures the data transfer by avoiding direct inputs in the mutation string. Error handling is another critical aspect. In GraphQL, mutations can return a payload that includes error details should they occur. This feature is invaluable as it provides immediate feedback on what went wrong, helping developers to quickly address issues. For instance, if an error occurs while creating a user, the mutation can return specific error messages and codes, making troubleshooting a breeze. In summary, GraphQL mutations are essential for any application that requires direct manipulation of server-side data. They offer a structured, secure, and efficient way to modify data while providing mechanisms for error handling and dynamic data input through variables. Understanding and implementing these mutations correctly ensures that data management processes are not only robust, but also optimized for performance and security. Thus, mastering GraphQL mutations is indispensable in the toolkit of modern developers.